part 2 of the systems of equations homework, and we're going to start with question 11, and we're going to go through to question 20. Okay. All right, so this one I'm going to solve using elimination because that is probably the easiest method for these because as you can see, my y's already cancel out, okay? So this is an understood one. It's going to give me a negative 2x equals, if I add those two, a negative 14. Divide both sides by the negative 2, and I'm going to get positive, because I have two negatives, a positive 7. Now let's substitute that back into one of the equations. Really, neither equation is easier than the other, so I'm just going to choose the first one. Subtract 7, subtract 7. Divide both sides by 3. My y is going to equal negative 2. So my system, my point of intersection, is going to be 7, negative 2. All right, let's try number 12. I'm going to do this one by substitution. But the next one, just in case you're wondering, I'm going to do elimination on that one. All right, I'm going to multiply this one by an 8. So my new equations, the first one stays the same. And my second one, everything gets multiplied by the negative 8. So I'm going to have a negative 40x plus 8x equals, what is this? Let's figure it out. 8 and then 7 more is going to give me 152. That kind of sucks as a number. All right, so I'm going to work backwards this time. 172, and those cancel out. Negative 43x. Okay, can 43 go into that? Let's see. I'm going to see 4 times. 1670. Look at that, how perfectly that went in there. So I'm going to divide both sides by the negative 43, and it's going to go in a negative 4 times. Okay, I'm going to put this number back in the first one. Neither one is very easy, so why not? All right, I'm going to subtract 12 from both sides, giving me a 8 on this side. Divide out the negative 8, and y is going to equal a negative 1. All right, so I said that the next one will be substitution. Maybe it'll be slightly easier. We'll have to see. Number 13. All right, so the second one is the one I'm going to put in terms of y. So everywhere I see a y in the first equation, I can put x plus 3. I'm going to distribute out. All right, negative 3x plus 3x, they're going to cancel out actually. And I'm going to have 9 equals 4. Well, that's not true. 9 does not equal 4. Well, that's because this is these are inconsistent equations. So the answer is actually no solution. You can either use that or say no solution. But it means that the equations actually never touch. And actually, I can do a little test here on these equations. They're more than likely perpendicular. So there are a couple rules to perpendicular lines. Number one, cannot have the same y-intercept. Okay, they also have to have opposite. That means if it's negative, it's positive. Reciprocal, that means if it's 1/3, then it's 3. That's spelled wrong. Slopes. So in order to know, I need to rearrange these, okay? So for the first one, it's going to be 3y equals 3x plus 4. Divide out my 3, and I have y equals x plus 4 over 3. In this one, I'm going to go ahead and move it around. It takes 2 seconds. So they have different y-intercepts. Checkmate. And, well, they don't have different slopes. That is kind of weird. They both have a slope of 1 over 1, which is reciprocals of each other. But one should be positive and the other should be negative. Okay? And let me just double check that I wrote everything down correctly. All right, so these don't touch at all. They are not perpendicular lines. One would need to be a negative. One would have to be decreasing while the other one is increasing, but they are inconsistent equations. Okay, so let's go on to number 14. Okay, so number 14 reads negative 3x plus 3y equals 3, negative 5x plus y equals 13. I'm going to solve this one with elimination, okay? Because we did substitution last. So I'm going to multiply this whole entire equation by negative 3 because that is going to give me what I need in the y term to have it cancel out, right? So I'm going to rewrite my first one. That one's good as gold. Let's multiply this bad boy through. All right, let's do some math. Let's add these. Okay, negative 3 plus a 15x is going to give me 12x. A positive 3y and a negative 3y is going to give me 0. They cancel out. But a 3 plus a negative 39 is going to give me a negative 33. All right. Negative 36. Oh my goodness. Oh my goodness. Didn't think that sounded right. To get x by itself, I have to divide both sides by that positive 12, which is going to give me a negative 3. Okay, because 3 times 12 equals 36. And I have a negative and a positive, so my answer is going to be negative. Really doesn't matter which one I put this in. It's going to be just as long, just as much of a headache to solve. So I'm going to substitute this back in for the first equation, since it doesn't really matter. And that gives me all 3's. That might be a little bit easier. So a negative 3 times a negative 3 is going to give me the positive 9 that I need. I'm going to move this 9 to the other side, which is going to make it negative. That way I can get this y by itself. And to further get the y by itself, I need to divide by that 3 that is being multiplied to it. That's going to give me a negative 2. So my coordinate point for this one is a negative 3, negative 2. All right, 6 more, you guys. Let's do number 15. All right, so I did elimination on the last one, so let me do substitution on this one. The second equation, the 5x plus y equals negative 13, is probably the easiest one to manipulate, so I'm going to make it a y equals negative 5x minus 13. Okay, so everywhere I see a y in the first equation, I know what it equals. It equals negative 5x minus 13. Okay, this means I'm going to have to do some distributing. All right, so I'm going to distribute through the 6. Okay, now I got to get these like terms together. So I have a positive 6x and a negative 30x. If I combine those, I'm going to have a negative 24x. Now I need to get that negative 78 to the other side. Well, it's subtracting the x, so to move it, I have to add it. Got to do opposite operation. All right, that's going to give me a 72 on that side. All right, I'm going to divide out. Okay. And that is going to go in 3 times. Because I have a positive and a negative number, it's going to be a -3. So my x value is a -3. Again, there's not a easy equation to substitute this back into. So I'm going to substitute it into the second one. Just because I have a coefficient of 1 in that one makes it slightly easier, but really it's 6 of one, half dozen of another. All right. Okay, so 5 times a -3 is a -15 plus y equals -13. Gotta add this 15 to both sides because it's negative over here. And that is going to give me a 2. That was actually quite painless. So -3 and 2 is my coordinate point of intersection. All right, let's do elimination this time. I'm going to multiply this by 5. Or I could do a 3. Let's do a 3. I haven't done x in a while. I'm going to make it negative. All right, so I have a -6x minus 3y equals a -60. Just going to copy that one over. My x's are going to cancel out, and a -3y plus a -5y is going to give me a -8y. A -60 plus a 12 is going to give me -48, right? Yes. Okay, now I'm going to divide out. Y is going to equal a 6, and it's going to be positive because both of my numbers, top and bottom, that I'm dividing are negative. All right, so I have my y value. I'm going to go ahead and put it in the top one, though I really don't think it matters again. Subtract 6 because it's being added to the 2. Divide by 2 because it's being multiplied to the x, and I get 7. So my coordinate point of intersection is 7 and 6. All right. We're in the home stretch, you guys. 4 more problems. Ooh, I was going to do substitution next, but this one is set up so beautifully for elimination. So let's go ahead and do elimination. All right, so these two, the x terms are going to cancel out, giving me a -y equals -1. Okay, so I multiply everything by a -1 and y equals 1. Look how beautiful that was. That was pretty awesome. All right, so let's go ahead. Doesn't really matter which one I put it in. There are less negative signs in the second one, so I'm just going to put it in that one. So let's substitute our y in. Gotta subtract the 3 from both sides because it's being added to the x. Divide out my 3. X equals a -2. So my coordinate point of intersection is -2 and 1. All right, awesome, awesome, awesome. We are almost done. Now on to number 18 out of 20. All right, so let's go ahead and do substitution on this one. I'm going to go ahead and rearrange the top one. It's not going to be pretty, but it'll do. It'll do. The elimination's not exactly going to be pretty on this one either. Okay, so everywhere I see a y in the second one, I need to put this. Let's distribute through. I'm going to get some ugly answers, but I think it's going to be okay. I know it's going to be okay. It's just numbers, people. So if I take the complement, then it's 6. Oh, wait a minute. Let me turn this into a mixed number first. That will make it a lot easier. So it's going to be -5, -4, because I'm actually taking away 3. Okay, so -4, and the complement of this fraction is 1/3. Could also get rid of the fraction. I'm not going to do that yet. I will if it starts to get difficult, but I don't see really a need at this current moment. Okay, I'm still holding out faith that it's gonna turn out good. Okay, so that's gonna be 13 over 3. I'm gonna have to divide it, so I might as well go ahead and get it looking like something I can divide. Right, when I divide fractions, I keep the first one, I change the multiplication, and I flip the second one. My two negative signs are going to turn to positive. 13s can cancel out, okay, which gives me a 3 on this side. So see, I told you it would all work out okay. So let's find our y. Both of them are pretty ugly. So I'm just going to put it in the first one because there's one less negative sign. Doesn't really matter. Put it where you like it. Alright, so that's going to give me -6 plus 6y equals 6. Add 6 on both sides. So 6y equals 12. Y is going to equal 2. So my coordinate point of intersection is 3, 2. 2 more questions, you guys. I wish we could do elimination on the points, on the constants, but we can't. All right, I'm going to times this one by 5, but that's not going to do it. So I'm going to have to multiply this one by 2. So I'm changing both this time in order to do my math. So my first terms are going to cancel out, okay? That's going to give me 21, 51. A -51y equals 151. A -51 over there. All that work, and it's just going to equal a +1 because I'm going to divide out a -51 on both sides. That ugly number ended up with a 1. Isn't that beautiful? Math is just so beautiful sometimes. All right, either one, pick your poison. I'm going to go with the second. Divide by 2, divide by 2, x equals a -5. I hear an ice cream truck. My coordinate point of intersection is -5, 1. Drum roll, please. We are on the last question. I'm so excited. All right, we're going to do substitution for the last one. So I'm going to rearrange this equation, multiply by my -1, and then substitute it into here. Okay, we've done this now a few times, so hopefully you're getting quick at it. All right, and this just gets rid of my y. So now I'm down to the variables I need to be able to do some math with it. All right, I'm going to add the 18 over there. That's going to give me 36. And x goes into 36 4 times. Okay, I'm going to put it into this equation. and y is going to equal positive 1. So my coordinate point on the last one of intersection is 4 and 1. As always, if you want to see one of these questions solved in a different way, just email me and I'll do so. And if you have any questions when you're working on these, you just cannot figure out what you're doing wrong, snap a picture of it, send it to me in a message, and I will see the way your brain is working and try to help you out. All right, keep learning math, you guys.